So as you are creating that reference sheet, these would be good shapes to make sure you have on there along with those equations, but also this very last conic section. And our last conic section is a parabola. And just as a reminder from last Wednesday, we've got our cone. We connect the two diagonals so that we can see our cone. And if we take a slice that kind of goes like this, then we'll end up with a parabola, okay? All right, so for this completing the square, all right, let's just go through and think about what square this looks very familiar to. All right, so we have x squared plus 8x. If I wanted to complete the square, what would I add to this to make this a perfect square?
Plus 4 squared.
Yeah, we're going to take that middle term. So this 8. So 8 divided by 2 gives me 4. And then 4 squared will actually give us the last term, x squared plus 8x plus 4 squared. But since we're adding that 4 squared, we also need to subtract it, right? When we're on the same side of things, we just do the opposite to keep it balanced. And then we could write this as x plus 4 squared minus 16. Yeah, and we could do plus 16 as well. If you didn't want to write 4 squared, you could keep it as 16, and that would be fine as well. Now, there is one Desmos activity that I would like you folks to take a look at. And this Desmos activity is about completing the square, but it's like a visual way of looking at completing the square. All right, it is a visual way of looking at completing the square. Please take a look at that by the end of this evening. All right, so by midnight tonight, I want to make sure that that's a skill that we feel really comfortable about. I know we took a very algebraic approach, which worked super well for some of you. And for those of you who are like, I don't really understand why we're cutting 8 in half and why we're squaring it, the visual way might be helpful in connecting why we do that particular process. So with that, let's move along. I don't know how many of you watch sports. I think not all sports have this sort of individual on the sideline, but in a lot of like football games, you might see someone carrying this sort of microphone situation. And the cool thing about the microphone situation, like if you're in a big stadium or a loud, place, the sound can be like all over the place. And so if you're thinking about wanting to record something, it's really hard for us to think about collecting all of that noise in a common place, all of that sound in a common place. And so when we have these microphone setups, it's actually a parabolic dish. So it is in the shape of a parabola, but like a 3-dimensional one. And it turns out that the microphone sits at a really important place in this dish, all right? And that is, that particular point has a specific name, all right? So let's draw that one first. We might have a parabola, less conventional for us, but one that sort of faces sideways, Okay, so modeling this after this parabolic dish that we see here. And what I'm saying is the microphone is at a very specific spot inside this parabolic dish. And in fact, that microphone is at what we call the focus. We have a vertex here, so singular, there's only one vertex. And it turns out that there's actually a line on the outside of this as well. Lots of vocabulary here. But this line is called a directrix. Okay. Now, the way I've drawn this as a vertical line, should that equation be x equals or y equals?
X equals.
It's going to be an x equals, perfect. X equals a number. This point is our focus. So there's only one of them because we only have one branch, so to speak. All right. And it turns out that there's a letter we're going to be using to talk about some distance, but it turns out that the distance from the center to the focus, we're going to call that little p, lowercase p. That distance happens to be the same as the distance from the center to the directrix. Okay. The reason why this focus is so important is when you have all these sort of sound waves coming in and they bounce off the dish, they actually, all of them go through the focus. And so if we have a really noisy space and we have a parabolic dish with a microphone in it, and the microphone is at the focus, it turns out that because the microphone is at the focus, it actually captures all of the noise that's coming through and gives us something that we can actually hear. Now, if we draw a more traditional parabola, there we go. If we draw a more traditional parabola, meaning we have one that's sort of facing up and down or up or down, excuse me, we have something like this. Our vertex would be here. Where would our focus be? If someone can describe to me where that focus might be. Yeah, it's going to be above that vertex, right? So we have our focus somewhere in here. And so what would the directrix look like? Yeah, our directrix is going to be a horizontal line. And so that equation would be a y equals a number. Okay. And same idea that the distance from the focus to the vertex, we call that little p, is going to be the same distance as from the vertex to the directrix. Okay. So that's sort of the kind of graph that we're looking to create. Again, we'll walk through it sort of like reasoning our way through it. But if you like having equations here, here's a list of sort of what we're looking at and how you know whether something is going to be opening up or down, or where that directrix is, or how you find that focus. Okay. As usual, let's kind of jump into our equations and kind of see what they tell us. All right. And let's take a look at this first one right here. So before we even get started with this, can someone tell me why this is not a circle equation?
Is
The
it because,
minus?
oh yeah.
Oh, sorry. I don't really know why.
I think it's because if you like move them to one side, then it would be equal to 0.
Yeah, that's a good clue, right? If I move this to the other side, I do end up with a 0 on that side. And whereas when we have a circle, we usually have a number on the other side, right? What's another clue? Oh, I see it in the chat. This y has a square with it, but what's the power for the x term? It's just 1, right? So it turns out that for like our ellipse and our hyperbolas, both of them were squared. But when we only have one of them squared and the other one is not, that's a really good clue that we have a parabola. Okay, so all those little exponents are definitely important to look at as well. All right, so we've got ourselves a parabola here. Do we think this parabola opens up and down or side to side?
Up and down.
Up and down. What makes us say up and down?
Because the y is squared.
Okay. So let's go back up to our table and kind of see. Normally, when we think of a parabola equation, we write like y equals x squared. And something like that would open up or down, right? So in this case, let's use something that we know, these graphs, x squared means our parabola opens up and down. That means that if we have a y squared, it's actually going to be opening to the right or to the left. Okay. So we want something like this or this. Now, let's actually start with the vertex here. Okay, let's start with the vertex. So where is the vertex if we think about it like the center of a parabola? Can you tell me what the x coordinate is of this quote unquote center for the parabola? Nice, Matt. Yeah. We're going to look for the x, right? X plus 3. That means if I solve for x, I will get a -3. And the y coordinate for the center is going to be 1. All right. So I like it. Between our two answers up there, we've got a complete answer. We have a center of -3, 1. But since that is sort of the main point for the parabola, we call that the vertex. Okay. So our vertex is going to be at -3, 1. Now, I could sort of sketch the rest, but I want to make sure I know where my focus is and where my directrix is, all right? And so what would be important to figure out is if I knew the p-value, then I could find out where the focus is and where the directrix is. So let's go back up to this chart for a moment, okay? It turns out that the coefficient in front of the term without the square. Let me say that one more time. The coefficient in front of the term without the square is equal to 4 times p. So if we look at our equation, that means 4p equals -4. 16. If we solve for P, we get -4. Here's what that means. That means from my vertex, I'm going to go -4 to find my focus. So 1, 2, 3, 4. Oops, our focus, we used purple. Let's keep in line with that. Does my parabola open to the left or open to the right? Exactly. It's going to open in the direction where the focus will be inside of that. Okay. So this, I can just sort of sketch this part, but I do want to make sure I have the proper vertex and the proper focus. All right. So let's think about that focus. I did -3. I subtracted 4, 1, which gives me -7, 1. All right. Well, if the focus is 4 units away from the center, how far away is the directrix from the center? It's going to be 4. And in particular, from my vertex, I'm going to go 4 in the other direction. 1, 2, 3, 4, and then I'm going to draw a vertical line. All right. And so if I write that equation, I'll get x equals -3 plus 4, because I'm going in the other direction now. Or I could say x equals 1 is the equation of the directrix. And so we can see here that this distance is 4. This distance is 4. And that's how we get our parabola.
Why was it +4?
Because from our center or our vertex, we're going in the positive direction 4 units. Right? Our P was negative for them, and we went this way to find the focus, but the directrix is in the opposite direction, so we would need to add 4. Does that clarify your question? Okay. Well, let's try another example. I think, again, the more we do, the more practice we get in here, the easier it is to kind of see like why we're adding or why we're subtracting. Okay. So let's try example number 2 here. All right, so example number 2, I've got x squared equals 8y. How do I know that this is not a circle, ellipse, or a hyperbola? Like, because right away I can tell it's none of those 3, but how do I know that?
One of the factors isn't squared.
Exactly, right? And so in particular, x is squared, but y is not squared. And so we can say that this is a parabola. And do we think it's opening up or down or left or right? Yeah, we're going to go with up or down because x is squared. up or down. And it turns out that once we find our p-value, that will tell us whether it's going to be up or down. Okay. Now, before we get there, can someone tell me where the vertex of this parabola is? Yeah, that vertex is going to be at 0, 0. Because if we wrote a more complicated version of this equation, we might say like x minus 0 squared equals 8, y minus 0. And that would make it a little easier to see that these two coordinates make up our vertex. So I could go ahead and draw that in. 0, 0. All right. From my equation, what does 4p equal? Yeah, 4p equals the coefficient of the non-squared term. So in this case, it equals 8. All right, well, p is going to equal 2. And that's a positive value. So that means from my vertex, I'm going to count up 2 units. In other words, my focus will be 0, 0 plus 2 or 0, 2. Do we have enough information to tell us which way our parabola opens?
Yes.
And so I hope that we would say, oh, this parabola is opening up. All right. The last piece we have to figure out is our directrix. So if it's helpful, you can draw it first. It's going to be 2 units below the center or the vertex. Y equals 0. Well, how do I get there? If I did plus 2, that would get me back up here, right? But from my picture, I know the directrix is down. So I'm going to do 0 minus 2, or y equals -2 is the equation for our directrix. All right. Does that help clarify a little bit more like why we add sometimes and why we subtract? Well, as you're working through these questions, I think it would be really important to just be thoughtful about like why you're making the decisions you're making. That's going to be, I think, the most effective way for these concepts to be sticky. And I know that's a lot of work up front. And maybe some of us are used to sort of memorizing our way through things. But I think the theme of this year, especially in an accelerated class situation, is that we really want to make sure that we are understanding why we're doing things, not just like how to do things. Okay. All right. So we're going to go ahead and skip example 3, but we're going to go down to example number 4. I think this is a worthwhile one to do together. All right. And so you'll notice here that we have this equation, and I'm going to ask you the same question I've asked you for the other ones, which is, how do we know that this is not a hyperbola, it's not an ellipse, it's not a circle?
X isn't squared.
Yeah, this x is just an x. And so that's a good clue for us that we have a parabola. And if the y is squared, that means that it's either this way or to the right. right? It's either facing to the left or facing to the right. And that's what we're going to figure out. But we have a little bit of work to do because it turns out that we need to complete the square first to get it into a more familiar form. All right, so let's practice completing the square here. And one thing that we're going to notice is we're only going to need to complete the square for the y's. And in fact, that's going to make it a little bit easier than completing the square with x's and y's because we only have one to worry about. Okay. So I'm going to go ahead and write this equation. 1/2 y squared plus 4y plus 11 equals x. Okay. Now, how many of you in here generally do not enjoy working with fractions? Anybody in here not really like working with fractions? I mean, some people really enjoy it, but sometimes I find they're a little painful. Well, one way that we can sort of get rid of fractions is look at the denominator here. We have a denominator of 2, right? So I'm going to say we multiply the entire equation by 2. What does 1/2 y squared become?
Y squared.
Yeah, it just becomes y squared. Good. What does 4y become? I'm multiplying the entire equation.
8y.
Yeah, I'm going to get 8y. What does the 11 become?
22,
What does the x become?
2x.
2x. All right. No more fractions, right? You don't have to do this, but I find that especially if we are working on some more complicated stuff, the less fractions we have, the easier we can make it for ourselves to look at. Sometimes that just helps us move through the problem a little bit more easily. All right. But we're going to do something very similar to what we did with our completing the square and the other ones. We're going to group our like terms. And then the term that we're not really interested in, we're going to move that to the other side so it can wait over there while we're completing our square. And so in this case, that'll give us y squared plus 8y equals 2x minus 22. All right. To complete the square on the left, I get y squared plus 8y plus, let's see, half of 8 is 4. 4 squared gives me 16. And if I add 16 to the left, I'm going to have to add 16 to the right. All right. The left-hand side becomes y plus 4 squared. And the right-hand side becomes, let's see, 2x. And what happens when I group these two together?
You get -6 or
Yeah.
2x minus 6.
Perfect, perfect, right? And we just really want to make sure we keep that negative sign with the 22 in front of it. So -22 plus 16 gives us -6, all right? And so it turns out we are super close to having this equation in the form that we want it in. We're going to have y plus 4 squared equals, we're going to take out a common factor on the right-hand side. We get 2 parentheses x minus 3. Okay. All right. Where is our vertex? Let's start there. Where is our vertex?
3 comma -4.
Very nice. 3 comma -4, because we need the x to give us the x coordinate, and then we need the y to give us the y coordinate. All right, so let's go ahead and draw that in. 3 comma -4. 1, 2, 3. 1, 2, 3, 4. That's not right. Thank you. 1, 2, 3 in the positive direction and then down 4. How's that look? Better?
Better.
Better. Okay, great. Monday mornings, man. Monday mornings. All right. What does 4p equal according to our equation?
Two.
Good. Our 4p is the coefficient of the non-squared term. So 4p equals 2. What does p equal then?
1/2.
Yeah, 1/2. Now I wanted to do an example where that p-value might not be a whole number, because I think it's important to see it's okay to not get a whole number. All right. It's always worth double checking, right? But sometimes we're moving too fast and we're like, oh, p equals 2, right? But I know if we took our time, we would get p equals 1/2. All right, so the p is a positive 1/2. What does that mean about where I should go from my vertex? Do I go up or down, left or right? What am I doing?
Right by 1/2.
Ah, all right. So you know what? We've done so much work, but if we go back to the little note we left ourselves at the top, we know our only options are right or left. And since our p-value is positive, we're going to go to the right 1/2. Okay. And that can be so easy to forget, especially as we're doing all this other more complicated work, which is why I find if I sort of do a little brain dump and a little, this is what my answer should look like in the beginning, it sort of prevents me from making those mistakes. Okay. So our focus would be 3 plus 1/2 comma -4. How do I get the equation for the directrix?
You do the opposite, so -1/2. 3
Yeah,
minus 1/2.
good, good, good. So 3 minus 1/2 will give me something like this as my directrix. Then we can sketch the rest in. And there, my friends, is our parabola facing to the right. And we've got our focus, we've got our directrix. And so we've got all the different pieces that we need there. All right. So again, I wanted to do one that we had to complete the square, but also had a fraction so we could think about how we might want to handle those situations, okay? But the last thing I want to do to finish up today is just take a look at that idea of going backwards, right? So sometimes we need to actually write the equation. And this is meant to be a 5. This is meant to be a 6. This is meant to be a 7, okay? So just like the other ones, we're looking for an equation of a parabola. Well, the other ones we were looking for like a hyperbola or an ellipse, but thinking about finding that equation given the information. Now, one thing that I want to note here, this parabola does not necessarily have a vertex at the origin. All right, does not necessarily have a vertex at the origin. And so it's going to be even more valuable that we sketch a quick picture just to make sure that we know where that vertex is. Okay. All right, so let's start with number 5. And I'm going to go ahead and draw on my focus at 2, 0. And my directrix is going to be at x equals -2. So which way is my parabola facing?
Like it's facing sideways
It
to
is facing-
the right.
Yeah, exactly. Any guesses as to where the vertex is? Like a specific coordinate. How did you know that, Matt? Because you're absolutely right. That center or our vertex is right at the origin. Any ideas? How do we know that that's where the center is, where the vertex is?
Is it just because that's like in the middle between the focus and the directrix?
Exactly. It is literally halfway in between, right? From -2 to +2, right in between should be our vertex. And so that's going to be right here at 0, 0. Okay. All right. So we know it opens sideways. So we want a y minus k squared equals 4p x minus h. We know that our center or our vertex is just 0 and 0, so we can fill those numbers in. What number should we put in for p? Yeah, we're going to go ahead and put in a 2 for p. And the reason is that this distance right here is 2. All right, so we're going to get y squared equals 4 times 2 times x, or y squared equals 8x. All right. Now, again, it's not always going to be that our vertex is here, right? We're going to see in number 6 that it's not that way. But if we have enough information, we can still figure out where all the different points go, okay? And so for number 6, we have some different information. And we have actually the coordinate of our vertex. And let's hope I count in the right direction this time. We're going to go 2 to the left, 3 up, and there is our vertex. And our directrix is y equals 5, which is going to be somewhere here. All right, which way does my parabola open? Up, down, left, right? What do we have? It's going to be opening down. What is the p-value? Great, great, great. This distance is 2. So I could even draw in my focus. It would be like 2 more units down, right? Okay, well, let's think about our equation. The ones that open up and down are like an x minus h squared equals 4py minus k. All right, I got to put in my h and my k and my p-value. So h is going to be, let's see, x plus 2 squared, because I changed the sign, equals, let's see, let's leave some space, and then y minus 3, because I changed the sign. What does 4p equal? In other words, what is that coefficient equal to? Super close. I totally get where you get the 8 from. There's one small detail we're missing. Let's think back to, I think it was Ellie's question about like how we know if we're adding or subtracting. Yeah, so from my vertex, I counted down to get to my focus. That means my p is a -2 value. Yeah. And so if we were to clean this up, we get x plus 2 squared equals -8y minus 3. Yeah, so a little tricky there, but that negative sign, whoops, that negative sign matches the fact that we have a parabola facing down. Okay. All right, let's try one more here. Let's do number 7. Got our coordinate set up so that we can graph some things. All right, our vertex is 1, -2. So I have 1, -2. My focus is at 1, 0. Based on this, which direction is my parabola facing? Yeah, it's going to be facing up, right? I don't know exactly what it looks like, but I know it looks something like this. My directrix would be somewhere down here. And I'm wondering, based on the diagram, if you folks can tell me what the p-value is here.
Positive 2.
Good. Love it. Love it. All right. So if it's up or down, it's going to be this equation right here. We just got to fill in our different numbers. So we're going to get x minus 1 squared equals 4 times 2. Now it can be positive, which makes sense because we want a positive coefficient to make it face up. And then y plus 2. So we'll get x minus 1 squared equals 8. y plus 2. All right, so my friends, let me go ahead and leave that all on one page for you, all right? And notice that there are definitely examples we did not go over, but they're ones that you can use for extra practice. I know that that exam is coming up. Some of us really want to do well on this. And by some of us, I mean all of us. I don't think anyone is walking in being like, ugh, I'm just not going to try it all, right? And so whatever that means for you in terms of how you want to do, I think there's plenty of built-in extra practice in addition to the quiz to kind of give you a little bit more support as you practice and study for that exam. Okay. So we're going to stop our video here.